All right, so in this video, we are going to be comparing different expressions that have exponents in them. So saying which is greater or which is less by using all of our exponent rules. All right, so first thing we're going to do is I have 2 to the 13th power, and I want to write 4 equivalent expressions to that. So first I'm going to think about my exponents with multiplication rule. Say I had 2 to the second power times 2 to the 11th power. I know that I would multiply those both and add the exponents to get 2 to the 13th power. I could also, really any combination of numbers that equal 2 to the 13th. I could have 2 to the 10th multiplied by 2 to the 3rd. That would also give me 2 to the 10 plus 3, which is 2 to the 13th. So those are ways I can use my multiplication or my product rule. Now let's think about division rule. Remember, so we're going to be subtracting the exponents when we're dividing. So if, say, I had a 2 to the 20th on top and a 2 to the 7th on the bottom, I know that I would be subtracting those exponents. Oh, that kind of looks like a 30. That is a 20. I would have 2 to the 20 minus 7, which would give me 2 to the 13th. I could also think of my any other subtraction combo. I could do 2 to the 15th over 2 to the 2nd, which would also give me 2 to the 13th. So just a little warm up there about how we can use those rules to make the same expression. All right, which expressions are equivalent to 5 to the 8th? All right, so if I have 5 to the 1st times 5 to the 8th, if I'm multiplying, I'm going to be adding the exponents, which would be 5 to the 9th, which is not the same as 5 to the 8th. Now let's look at number 2. Again, my product rule, I'm going to add the exponents. 5 to the 2 plus 6 does equal 5 to the 8th, so number 2 checks. Now I have a quotient rule, 5 to the 16th minus 2, because when we're dividing, we subtract the exponents, would be 5 to the 14th. That does not match up. Now I have my power to a power rule. So that means I'm going to multiply those exponents. This is 5 to the 2 times 4, which is 5 to the 8th. So numbers 2 and 4 would both equal 5 to the 8th if we use our exponent rules. All right, use greater or less to compare each statement. All right, so I have 3 to the 6 on this side and 3 to the squared times 3 cubed on the other side. If I evaluate this, this would be 3 to the 2 plus 3, which would be 3 to the 5th. So I have 3 to the 6th and 3 to the 5th, so 3 to the 6th would be greater. Here I have 7 to the 4th, and here I have 7 to the 8 minus 4, because we're dividing, we're subtracting the exponents, which would be 7 to the 4th. So those are going to be equal. All right, I have 1/4 to the 16th power and 1/4 to the 8th times 1/4 squared. I am multiplying the same base, so I'm going to add the exponents. This would be 1/4 to the 8 plus 2, which would be 1/4 to the 10th power. So remember, so I know that 16th looks a little, looks like it's a bigger exponent, and that would be bigger. But remember, when you're multiplying with fractions, the more times you multiply it, the smaller you're going to get, because your denominator is just going to keep getting bigger and bigger, which makes a smaller fraction. So the 1/4 to the 16th is actually going to be less in that case, because the more times you multiply a fraction, the smaller it's going to get. All right, I have 9 to the 12th. Is that greater or less than 9 to the 36 over 9 to the 3rd? This would become 9 to the 36 minus 3, which would be 9 to the 33rd. So 9 to the 12th is going to be significantly less than 9 to the 33rd. Again, we subtracted those exponents because we're using our quotient rule. All right, so here's where things might get a little tricky. You can compare. So say they don't have the same base, we can actually make them have the same base. So if I have 5 to the 28th, and then this base here is 25, but I can actually turn that 25 into a 5 squared. So this is really 5 squared, because that equals 25, raised to the 19th power. And now I can use my power of a power rule and multiply those two exponents. 19 times 2 would give us 48. So this is really 5 to the 28th. Sorry, 38, not 48. This would really be 5 to the 28th compared to 5 to the 38th. So 5 to the 38th would be bigger. Again, so I got that 5 squared because I got this because I know that 25 is 5 squared. So I just changed that base to say 5 squared. So this is really 5 squared raised to the 19th power. If I multiply those two exponents, you would get 5 to the 38th. And now I know that 5 to the 28th is, less than 5 to the 38th. Sorry about that. All right, so now let's kind of put that into action here. I have 3 to the 18th over here. That's pretty standard. And then I have a 9 here and a 3 here. So I can actually change this 9 to say 3 squared raised to the 10th power. And then 3 squared to the 10th power would act, so then that would be 10 times 2, using our power of a power rule, would be 3 to the 20th. Then times 3 to the 3rd, which would be 3 to the 23rd. So 3 to the 18th is going to be less than 3 to the 23rd. Again, I got this because I changed that 9 to a 3 squared. 3 squared to the 10th power is actually 3 to the 20th power if you use your power of a power rule. And then multiplied by 3 cubed, we would add the exponents because that's our product rule, and we'd get 3 to the 23rd. All right, now here, we need to change we have 3 different bases here, which is going to be a little tricky, but I can use, I can change these 2's and 4's. We know that 4 is going to be 2 squared raised to the 21st. And then we're using our power of a power rule, so we're going to multiply those exponents. 21 times 2 is 42. So this is 2 to the 42nd. This 8 squared is actually 2 to the 3rd power, if we remember back to our perfect cubes day. 2 to the 3rd power raised to the 4th. 4 times 3 is 12. So this is actually 2 to the 12th power times 2 to the 28th. Add those exponents, you would get 2 to the 40th. Because again, my product rule says we add the exponents. So 8 becomes 2 to the 3rd power, raised to the 4th power, we multiply those exponents, you get 2 to the 12th. And then we still have to multiply it by that 2 to the 28th. 28 plus 12 is 40. So 2 to the 42nd is going to be greater than 2 to the 40th. All right, last but not least, use greater, less, or equal to compare. So first thing I need to do is I'm going to change, we're going to make these all bases of 3. I know that 27 is 3 to the 3rd power, and that's going to be raised to the 5th, which would be the same as 3 to the 15th power. This 9 is going to be 3 squared raised to the 8th power, which is the same as 3 to the 16th, because if I use my power of a power rule, over 3 to the 4th would be the same as 3 to the 12th, because when I use my quotient rule, I'm going to subtract. So again, 9 becomes 3 squared, and then we're going to multiply those two exponents because it's 3 squared raised to the 8th power, so that's my power of the power rule. We multiply. So that becomes 3 to the 16th over 3 to the 4th. You subtract those exponents, you get 3 to the 12th. So 3 to the 15th is greater than 3 to the 12th. All right, we are going to go over this, so don't panic if you are a little lost. But for now, finish up and we will talk soon. All right, bye.